everybody. This video is a little review of solving systems of equations, specifically when graphing. So the first example that I'm going to provide here is when both equations in the system are solved for y already. So the first equation I'm going to write is going to have a negative slope, and the second equation I'm going to write here has a positive slope. There is another video that I'm going to be uploading that'll have a system that has both equations that are in standard form, where we have to solve for y before we graph. So I changed this to graph paper because that's how we solve using graphing. And I put a little axis there in green. To remind ourselves of the steps for solving systems of equations using graphing, the first thing you want to make sure before you do anything is to solve each equation in the system for y. Then you actually have to graph the equations, and then you're going to look where the two equations intersect, and then the actual coordinate or ordered pair is the answer to the system. So the first equation that I'm going to graph here is the top one, y equals negative 2/3 x minus 3, and I'm going to color code that in pink so that we can recognize the two different ones. So the step in order to graph an equation, if you remember, when it's in y equals mx plus b form, is to plot the y-intercept first, then use your slope to generate more points. And remember, the y-intercept is the b. It's the constant when it's solved for y, right? So in both of these equations, the constant is negative 3. So that goes on the y-axis. I just plotted that. And then I'm going to use my slope of negative 2/3. I go down 2, right 3, or I can go up 2, left 3. Only one negative move. Remember, Mr. Slope guy, if you put him to the left, goes downhill, okay? And then the second equation I'm going to graph in orange. And the y-intercept for that is also negative 3. And plot that, and then the slope this time is positive, so we get to go up 1, right 2, up 1, right 2. Or we get to go down 1, left 2. When we connect all those points, you can see they match at 0, negative 3. This is our point of intersection, and it has to be written as a point, which you can see below. Thanks. See ya.